Right. Well, I'm going to get started here. Looks like the class has been thinning itself a little bit again. I guess it has to be the break that's doing it. Maybe some people did not realize that it's time to come back to school. It's like spring break. But spring is not over yet. Why would spring break be over? Doesn't make any sense. All right. So I'm going to get started. Are there any questions about the homework assignment that is due on Wednesday? Yes?
I just had a question on how many possible test cases we could have, because the code I've written, it works for an array of 5 members.
Okay.
It won't work for anything lower. So is that something we're going to have to work for?
Well, the subroutine that you're writing should handle any number of elements in the array, depending on what is passed to you.
So if the array has 5, it should be ready to handle 5.
That is correct.
Okay.
But if the array has 7, then your subroutine should be able to handle 7.
Yeah. But you're not going to ask the array is ready for 7, but you're going to ask for 4.
Well, your subroutine will be passed that information, right? So you will be passed both the beginning of the array as well as the number of elements in the array.
Okay.
So you have to use the second parameter of the function to determine how many elements it has to deal with.
And you would have to change the constant?
Well, that's one way to do it, but that's not the only way I can test your subroutine. I can always give it less, right? I can give it fewer. When I test your subroutine, I can give it fewer number of elements.
But it's going to be always expecting something for input. If you don't put anything, then how is it going to know?
That part is done by the main subroutine already, or not? No, it's actually your subroutine.
Every time you input something, it's waiting for you to put the 5th one. If you don't put the 5th one, it's not going to do anything.
Okay, so let's go take a look at the code, and then we'll then we'll see what you need to do. Okay. So, this is fractions and all right. So this is the subroutine that you're dealing with. For whatever reason, they made this screen a lot, over project. I think it's for the widescreen format, but it's actually not increasing the resolution of the screen. It's just making it look bigger. So I have to be careful of which part of the screen I can use. All right, so this is your homework assignment. This is the part where you will read a single fraction. Okay, so this is not going to read all the fractions all at the same time. It's only going to read one at a time. Is that okay? Is that answering your question? Okay. So the other one is printing only one fraction at a time. This one only prints one fraction at a time. Okay. So, and then for this one, you're starting on line 14. This is where you have to do you basically have to change all the fractions to use the same common denominator, which is going to be the LCM, or the least common multiplier. And then you have to change the numerators accordingly in order to preserve the values represented by each fraction. And with this particular function, the second argument, which is n, is the one that determines the number of elements in the array that you have to deal with. So you cannot make an assumption that there are always only 5 elements in the array. You have to utilize the second parameter of this function in order to determine how many how many elements are we dealing with? Okay. So what we need to do, or what you don't have to do, is something that I can change. Is in main. So I can make changes to main so that number fractions, I can change it to 7 and test your program accordingly, and it should not make any difference as far as you are concerned, because you are writing the subroutines that only have to deal with one fraction at a time, or you have to deal with a whole array of fractions, but the number of elements in the array is specified as a parameter.
Yeah. I think you misunderstood probably our question. It's like, for example, for this one, so for example, I'm just talking about my program. If I change num fractions into, for example, 100, it will do 100
Yes.
elements in an array.
Yep.
But like, for example, if I do like 100 and then in my input I just input 5 fractions, it's still going to be waiting for me and asking me to actually input more.
Because it wants 100 fractions.
Yeah.
There you go. Yeah. So
It
that's
wants to
actually-
fill in the entire array.
Okay.
Okay.
So that's your question?
Yeah. Yeah.
Oh, okay. I see. I got
What
you
if
now.
you don't? What if you don't fill it up?
It's not going to do anything.
Then you just go and do it.
Yeah, it's just going to be waiting for you.
Because it's still in the loop. Because with this loop here from line 30 all the way up to line 33, that loop wants to read into every single element in the array. If the array has 100 elements, it's going to read 100 fractions,
Yeah.
right? Okay, so I'm glad we got that clarified. Any other questions regarding this particular homework assignment? Does everybody know how to do the LCM thing? Okay, at least by hand first, okay? Find the least common multiplier, okay? So how do you do it by hand? Let me just kind of go through this first, just to make sure that everybody knows the basic idea of how to find the least common multiplier. So we'll go ahead and use, I don't know, we'll just use a little notepad thingy for this purpose. If I give you two numbers, okay, so let's not consider 100 or 5, we'll just consider two numbers. How do you find the least common multiplier when you have two numbers? Okay, so let's work with some concrete numbers first. Okay, so let's start with 14 and I don't know. I'm just trying to think of whether I should pick one that has a common factor or not. Let's pick one that has no common factor. So if I want to find the least common multiplier and LCM of 14 and 3, how do you figure that out?
Get to 14.
Sorry?
Get to 14. Check if that's a multiplier though. 15, 16, 10. So.
Okay, so you can basically just keep going up until you find one that can wholly divide both of those numbers. Yep, go ahead.
You basically prime factor it.
Yep, exactly.
Multiply those times.
That would be the more efficient way to do it, is to find all the prime factors of each number and see how many. Basically, you have to find a subset, or you have to find a set so that each one can be expressed as a subset of those prime factors. Okay, how many people have a concept of understanding what is a set, what is a subset, and so on and so forth? Some people. Okay, so I'm going to assume that not everybody understands that concept. So with 14, it can be expressed into 2 times 7, and 3 unfortunately is a prime number by itself, so it can only be represented by 3. So the question now is, how do I create a collection of numbers such that each number can be expressed by a multiplier of those numbers? In this case, you don't really have a choice. So your only choice is to combine 2, 3, and 7 as factors and multiply these together, and that will become 42. So 42 is the least common multiplier of these two numbers. The other way, which also works in this case, is just a little bit more time consuming. It's just keep increasing the potential least common factor, least common multiplier, until 14 and 3 can be divided with no remainder. Okay, that's kind of the easier way to do it. It's not exactly efficient, but as far as your homework is concerned, that's okay. Okay, you can use that method to do it. Are there any questions about how to find an LCM of only two numbers? No questions?
How would you find the 2 and the 7?
2 and the 7?
What kind of code would you use?
Okay, so between a 2 and a 7, okay, let's try 1. Okay, what is the remainder of 1 divided by 2?
2?
No, the remainder of 1 divided by 2.
1.
Come on, you guys should know this, right? 1 divided by 2. And what is the quotient?
1.
0.
I only got 1 candy. I got 2 kids. Okay, how do I divide 1 candy to 2 kids, but not using fractions? Come on. The quotient is 0. And if I multiply 2 with 0, I get 0 back, and this becomes my remainder. So we have a remainder of 1. Okay? So is 1 going to be a least common multiplier? Or is it even a multiplier of 2? No, because of the remainder is 1. So what do I do next? Should I go to the next number, like 2, or should I go to the previous number, like 0? Next number, which is 2. Okay, so let's go to 2. What is 2 divided by 2? What is the remainder of 2 divided by 2? 0. So it means 1 requirement. What is 2 divided by 7? What is the remainder of 2 divided by 7? I have 2 candies and 7 kids. No, I don't want to have 7 kids, but let's say we have 7 kids to divide 2 candies. So we got, each kid has 0 candies, right? Because I cannot evenly distribute, 2 candies, with 7 kids, and I will have 2 remaining in my pocket. Okay? And because of the remainder of 2, is 2 a multiplier of 7? Nope. So what should I do? 2 does not meet both requirements because it has to be a multiplier of 2 as well as a multiplier of 7. What do I do next? Step up to 3, and if you have 3 divided by 2 has a remainder of what? I don't care about the quotient. I just care about the 1 here. So I don't even need to try 7 because if it doesn't meet the requirement of being a multiplier of the first number, I don't even need to bother with the second one. Is that answering your question?
Well, you said that one way to do it would be to keep adding 1 until you find one that's divisible by both of them. But
right.
How would you do it the other way to find the subset?
Mm-hmm. Okay. So if you wanted to do it the other way, what you can do is you can you basically have to find all the when you want to find the subsets, that means for each one you have to find out which portion or how to combine the prime numbers so that each number can find its own set from the collection itself. So the first thing you can do, there are several ways to do it. You can basically just multiply the 2 numbers together, and then you can find out whether you can find something that is find a factor that is not needed. You can take out things from the collection instead of keep adding things to the collection. I mean, how do you do it by hand? If I give you like 2 numbers, how do you do it by hand? I can give you, let's say 24 is one number, and I'll give you 18 as the other number. So how do you find the least common multiplier of 24 and 18? Not using the +1 method, okay? So how do you find it? With 24, it is expressed as 2 times 2 times 3, one more 2 here. So it's 2, 2, 2, 3, and then 18 is what? 2 times 3 times 3. Okay, so looking at 2, 2, 2, 3 on one side, looking at 2, 3, 3 on the other side, how do you combine these so that you have the factors of the least common multiplier?
Cancel out all the common ones?
Well, you want all the common ones, for sure, okay? So you take all the ones that are common, okay? This 2 and this 2 is common. So we'll need this 2 for sure, right? This 3 and this 3 is common. So we'll need this 3 for sure. But now we have this 2 and 2 left, and then this 3 left. These 2 is only remaining in the first number, and is not found in the second number. So we'll have to take both of these here. This one is only in the second number, but not in the first, so we have to take this one here. So 3 would go here, and then we have the 2 and the 2 here. Or am I doing it wrong? I think we got it wrong because we just
That's
need
right.
one of the two. Because these two, but we got the 2 taken care of, and then we got the 3 taken care of. We need one more 3. I think this is
That's right.
that is right.
Yeah.
Yes.
That number looks too big to me.
No, it's right actually.
The answer would be 6, right?
The LCM of these two should be
2 3s and 3 2s.
17.
You're right. Okay, so this seems right to me. Okay, so it's basically 8 here, and there's a 9 here. So the actual LCM is 72, which is correct. So you find out all the overlapping ones first, take care of those. So if a factor is overlapping, like this, the first 2 and the first 2 here, you just take one of them. And the 3 here is common too, so you only take one of them. And then for everything else, if it's unique to one of these numbers, you have to take it. You have to put it into the LCM.
I think I'm going to use the +1 method.
The plus method is a whole lot easier, yes. But doing it this way, is kind of resembling a little bit of what you had to do with the first homework assignment, which is to find, all the factors of a number. All right. Any questions about finding the LCM of 2 numbers? Now, once you can find the LCM of 2 numbers, do you know how to apply that to your homework assignment? Sorry?
That part is okay, yeah.
Okay. Because you just have to apply the LCM to all 5 numbers, right? So you have to maintain a running LCM of the first 2, and then the first 3 numbers, the first 4 numbers, and then all 5 numbers. And then you have to find out, okay, if this is the LCM of the denominators, you have to make adjustments to the numerators accordingly. Any other questions about the homework assignment? Questions? All right. If there are no questions about this, we'll go ahead and start with the practice exam, because we'll have exam number 2 next Monday, which is 1 week from today. I have not shared the questions yet, so what I'll do is I'm going to share it now. And change so that everyone who has a link can do it. And I'll put the link into Moodle, so this way you can find it as well. And let's see where we should put it. I'll put it inside the array topic. Just insert the link here. So this way you have access to that as well. You should find it now on Moodle as well. So on Moodle, you will find a link that has a name of Exam 2 Practice Questions. If you click on that link, you don't have to log into any account, because I opened up the document to anyone with a link to this document. So you should be able to access the test questions. Can anyone verify this? Okay, it's all good? All right. So the question, in this case is very much code-based. In other words, each question is in the form of me giving you the code, and you have to figure out what it does or what's wrong with it, or I might ask you some other questions regarding that. All right, this is question number 1. Question number 1 is asking you to assume that we have a file called id.txt. And the only content of this file would be your student ID, which is only the 7 digits of your student ID, and nothing else. There's no line feed character at the end of the line. It's just 7 digits, your student ID. And then I want you to observe the following program. This program has pound include stdio.h, has a single main function in it. Inside we have a local variable ch, and we have a while statement. The condition of the while statement is scanf double quote %c double quote %ch has to be equal to 1 to stay in the loop. And as long as we stay in the loop for each iteration, we print this statement here, and then we're all done. Okay? Okay, so the first question is, when am I getting out of the loop? What is the condition that will get me out of the loop? Whenever you have a loop, you have to figure out, when are we staying in the loop and when are we exiting the loop? In this case, when are we getting out of the loop?
When the scan doesn't equal 1.
When scanf returns something that is not 1, okay? How many things did I ask scanf to scan in this case? How many items am I asking it to scan?
1.
Only 1. So that means scanf can return which 3 possible values?
-1, 0, 1.
Exactly. It returns a -1 when it has reached end of file. It returns a 0 when it does not meet the requirement. But everything can be interpreted as a character. So in this case, it cannot return a 0. So basically, it can either return a -1 when we're at the end of file, which means there's nothing else to read, or it can return a 1 when it has 1 character to read and has just read it. Are we doing okay so far with this logic? Okay? So what I'm doing here is just reading a single character, and I'm reading it into ch, which is a local variable. The statement inside the loop is doing something like this. So what exactly is it printing? Okay, first of all, what is %d telling printf? It's a placeholder of a decimal. It wants to print an integer as a decimal number. In this case, what is the type of ch? Ch is a character, so that a character is not exactly an integer, right? So what am I doing to ch first? What is this int in front of ch? It's typecasting, exactly, okay? So typecasting is basically saying, well, I know ch is not an integer, but convert it into an integer. So now the question is, but hold on a second here. Ch is not even a number. It is supposed to be a character. So how do I convert a character into an integer? How are characters represented? You guys still remember the Ascii table? Okay, so let me switch back to this here. Okay. I'm hoping that most of you still remember the Ascii table, which is this table here. Your student ID only has 7 digits, right? So we'll look up the digits, which is down here somewhere. All right, so now we have the digits. So this means the digit 5 is represented by what? Well, what are the other columns representing? Let's go back to the first row of the table and find out what the other columns are. Okay, this column is representing the character itself. This column is representing the hexadecimal representation of the ASCII code. This is the decimal representation of the ASCII code, and this is the octal code. This all boils down to how do we actually represent characters. In other words, if your computer needs to send something to the printer to print it out, what is it transmitting? Okay, so let's say, okay, I'm hoping that you guys still remember this, because when we talk about files, we definitely talked about this. If I want the computer wants to send out my name, okay, just tag TAK, to a printer, and it wants to print out uppercase T, lowercase a, and lowercase a, and lowercase k, okay, TAK. What needs to be transmitted? That's the question. Well, first of all, the two devices, they have to talk the same language. because there are two different standards that can be used to transmit to specified characters. One is called ASCII, which is what you're seeing here, and the full name of ASCII is the American Standard Code for Information Interchange. This is the most commonly used standard today, but it's not the only standard. The other one is called Ascii, which we don't really use anymore. Okay, so assuming that both devices talk in ASCII, what is going to be transmitted? Okay, first of all, how do we classify most computers today? Are they analog or are they digital? They're digital. Okay, so we are not transmitting any type of sine wave or sound wave or anything like that. They're all in digital format. What is digital to you? What does that mean when we say computers are all digital?
Transistors?
Transistors, okay, but there's one thing that's specific about these transistors in a computer. What are the states of each transistor on a computer?
1 and 0.
They're all zeros or ones, okay? Very good. So that means when you're transmitting, something to print to a printer, when you look at the line of the transmission, what would you see on an oscilloscope? Would you be observing something like, maybe a higher voltage like this for tag, a slightly lower voltage for lowercase a, and a slightly higher voltage for k? Or would you be observing what else? This would be analog, right? Because we are depending on the actual level of the voltage to interpret what is representing. But since computers are digital, and more importantly, they're not just digital, they are binary. Okay, so when you look at the transmission, what do you think it looks like? They're all zeros or ones, right? In other words, we are looking at just zeros, ones, like that. This is what is being transmitted, and you can see this one as a 1, 0, 0. This can be a 1, 1, 1. Here's a 0, and so on. So this is actually what is being transmitted in order to print something from a printer that is connected to a computer. Are we still doing okay so far? Okay. So the bottom line is everything is represented only by zeros and ones. Even characters, even addresses, they're all represented by zeros and ones. How is that connecting to the ASCII table that we are looking at on the projector?
Each character will be interpreted 0 and 1.
Exactly. Okay. So what this is saying is, okay, well, we can look up this one here since it's just handy to look it up. This is the uppercase character A. Okay, uppercase letter A. What do you think it is represented? How do you think it's represented when you transmit it to a printer? It's a whole bunch of zeros and ones. We know that already. But exactly what is the pattern of the zeros and ones?
0, 0, 1.
Well, okay, what do you think the 4, 1, is representing?
Sorry.
The 4, 1 is not in binary, but it is in hexadecimal, right? But 4, 1 in hexadecimal is what in binary? What is 4? How do you represent 4 in 4 bits?
1, 0, 0, 0.
It'll be 0, 1, 0, 0. Okay? So 4 as a hexadecimal digit is 0, 1, 0, 0. What do you think is 1 represented by 4 bits? 0, 0, 0, 1. Okay. So together, this is the binary representation of the ASCII code of uppercase letter A. Are we doing okay so far with that? Well, what is the other way to look at this bit pattern? Instead of looking at this as uppercase A, which is the ASCII code of uppercase A, what is another way to look at this particular bit pattern? Can't we look at this as 1, 1, 0, 2, 0, 4, 0, 8, 0, 16, 0, 32, 164, and just look at this whole thing as, oh, hey, that is just 65. Can we do it that way? Sure we can. Do you see 65 somewhere on the projector? It's the decimal value of the bit pattern that represents uppercase A. Is that okay so far? So that means a character can be seen as just an integer value. It's a short one because how many bits are we talking about here? We're only talking about 8 bits, okay? So if you only specify 8 bits where 32 bits is expected, the compiler may get confused and go like, I don't know how you want to do this. But that's why we can use a typecasting operator. The int here is a typecasting operator. It's telling the compiler and say that, I know what I'm doing. It is okay to look at CH, which is a character, which is just 8 bits. But we are basically telling the compiler and say, it's okay to look at these 8 bits and just extend it out to 32-bit and print it out as a 32-bit integer. So it would just print 65 if the input character is uppercase A. Are we still doing okay so far with that concept? Is that okay? But this is your student ID. Your student ID does not have uppercase A. It has all just digits, right? So let me just give you an example, okay? So what if a student ID is exactly just 1, 2, 3, 4, 5, 6, 7? That's the entire student ID. What do you think this program should print out? Well, we'll print out the ASCII code of 1 in decimal. What is the ASCII code of 1 in decimal? Let's dig it up. And we are almost there. There we go. Okay. So looking at the ASCII table, what is 1? What is the ASCII code of the digit 1 in decimal?
49.
49. Very good. So it will print out 49. The next one is 2, and you can see all the digits are contiguous, which means they're right next to each other. So we'll print 49, 50, 51, 52, 53, 54, 55. Let's see, 1, 2, 3, 4, 5, 6, 7, and that should be it. That's the output of this program.
So in the exam, can we use the computer again or not?
Sorry?
Can we use the computer in the exam or not?
Say again.
Can we use the computer in the exam or not?
Nope, you cannot. Otherwise, you just have to. Otherwise, it becomes a typing exercise, right? You just type in the program, run it, and then you figure out what is the output. Yep.
And for something like this, would we be given the ASCII table, or do we have to have that?
I can give you the whole ASCII table. In fact, if you look at the question here, the first part I said is the ASCII code of 0 is 30 in hexadecimal. Now we did talk about hexadecimal, right? Base 16. So you kind of have to remember how to do base 16. Now, why do we use base 16? Isn't base 2 and base 10 quite enough already? Why do we have to talk about base 16? We talked about that too. I mean, I'm just trying to see if you guys can remember.
It's easily
Like not binary, right?
Sorry?
It's easy to like work with binary.
That is correct. But why do we want to use base 16? I know it's easy to convert between base 16 and base 2, okay? And that has to do with 16 being, how is it related to 2? It's a power of 2, exactly, okay? So between base 2 and base 16, the conversion does not involve any type of multiplication, addition, or anything complicated like that. It's just looking up a table, okay? And that makes it easy to look it up. But why even bother with base 16 when we have base 2 and base 10 on the other hand?
It represents greater number. Less.
It does not use up as many digits, okay? Because for every 4 digits in binary, we only need 1 hexadecimal digits. So instead of using 32 zeros and ones to represent a 32-bit number, we only need 8 digits in this case. Because 8 times 4 is 32. So it's much more compact to write numbers in base 16 and still be able to convert it into base 2 when we need to. Is that making any sense? Okay. All right. I can see anonymous turtle. Did I make it so that you guys can make changes to it? That might be the case. I need to know. Anyone who has the link can view.
It says view only on it.
Yeah, it should be view only. But I can see every, like anonymous armadillo, anonymous. So I think these are you guys. I don't think I can look at this document from this many different computers, okay? Because each one will be represented, like that. All right. Well, this is the power of Google Documents. For those of you who have not used Google Documents in your other classes, this is a really good tool for collaboration. If you need to work on a document with somebody else, this is a really good way to do it. But that's kind of besides the point here. All right. Are there any questions about question number 1? Question number 1 really just tests you on, do you understand what scanf does? Especially when the input is a %C, okay? And can you relate a character, which is CH, to an integer? Do you know how to typecast it into an integer? And so basically you're looking at the binary representation of an ASCII code, but you print it out as a base 10 number. Are there any questions about question number 1? I think the biggest question, is not so much scanf, because we have used scanf quite a bit. It's about the representation of numbers and the representation of letters, digits, and stuff like that. Okay. If there are no questions, I will move forward. During the debug time, not the debug time, during the lab time of today's class, I can go ahead and actually compile each and every single program and run it through GDB, so that this way we can actually stop the program on the printf line, and then we can look at the type of CH. We can use print in GDB to find out what is CH and do all kinds of useful stuff with that. Okay. Question number 2. Question number 2 is using a simple function. Okay. So can someone describe what function f is actually doing? If you just look at the description or the definition of f, what is it really just doing? It's just returning the product of the 2 parameters, right? Because the only thing it is returning is x times y. This is the value that it is returning, which means it's really just figuring out the product of 2 numbers and returning it. Okay. And then you look at this program, okay, you look at the main program, the main function. The main function starts with, let's go ahead and have a local variable x. Does this x have anything to do with parameter x of f? Nope. Well, not at this point. There's only one place where they will have quote unquote a connection, but at this point they are completely different things. And then the first line is here, which I made a mistake because I forgot to put a semicolon here. Okay. So I'm going to have to put a semicolon, and the document is automatically updated. For those of you who are looking, you should see the semicolon appearing just like that. Okay. What does this line do? It's just initializing x to a value of 3. Okay, well that's not really complicated. Then we move on to the line that is kind of ugly. How do you deal with a line like that? You just go like, oh man, this is too hard, I'm not going to do it. Or how do you do it? Group it. Okay, so which part do you evaluate first? The innermost part, right? Okay, so you have to analyze the parentheses and find out which part is the innermost, because we already know that f is just finding the product of 2 numbers, right? So we look at the innermost part, which is this part here. What is that evaluating to? X is 3, right? What is 3 minus 2? Just 1. 1 times 1 is just 1. So that means this part will first get evaluated, and whatever I'm highlighting here is going to be basically change into a 1. And we can see that there's a problem because I'm missing. Yeah, I'm having too many parameters.
Yeah, three parameters.
I'm having too many parameters. We'll take out this one. There we go. I think that's better. Okay, so we're taking out that one. This is still just evaluating to 1. And what about this part here? Have I changed the value of x? No, so x is still 3. 3 minus 1 is 2. So when you look at the second invocation of f, which has to be this one here, what is it evaluating to?
3 times.
It's evaluated to 2 times 1, which is 2. And I have one extra one here, so I'll take that one out too. I apologize for that. Okay, so now that we have figured out the innermost 2 invocations of f, because we know that this one is just 2, what is x? X is 3, and the second argument is 2. What is 3 times 2? That's 6. So by the time we execute the whole thing, x will be updated to a value of 6 by the time we get to the return statement. So the question is asking what is the value of x before the return statement in main, and the answer is 6. But there's a second question too. The second question of Q2 is f recursive? What do you think? It is not recursive because recursion means
Calling itself.
the function has to be calling itself. Okay, eventually calling itself may not be directly, but eventually it will be calling itself. When you look at the definition of f, does it mention f of something in the body of f? Nope, it's just a straight multiplication. So f in this case is not recursive. Are there any questions about number 2? Yep.
You say it returned 6.
Say again?
What did it return?
It returns 6 in this case. Well, that's after I made all the changes. Is that okay? So moving on to number 3, which is here. Okay. So 3 is something that we have seen already. Okay, this is nothing new. We have seen it already. In fact, I think I even mentioned this specific case last time when we talked about the swap subroutine. Okay, so we'll go ahead and go through the questions or what I'm asking in the question. What happens when this program runs? Okay, so to be more specific, you have to answer these questions. Does it crash? In other words, does execution does not reach? Oops, you guys cannot see it. Okay, so does it crash? Which means execution does not reach the return statement in main. Okay, you can either answer yes, it does crash, and execution does not reach the return statement in main, or you can answer no and say that it does not crash. If it does crash, where do you think in the program it will crash? In other words, what is the last statement it will execute in the case that it does crash? Now, in the case that you think it does not crash, you will have to answer this question. What are the values of variables A and B right before the return statement of main? In other words, right at the time I get to this particular statement in main, what is the value of A and what is the value of B? Okay, so obviously we don't quite know the answer until we track down the execution of this program. So let's go ahead and track down the execution of the program. The first thing we do is we start with main because that's the entry point of the entire program. Main has 2 local variables. One is called A and one is called B. A is initialized to a value of 3. B is initialized to a value of 7. Are there any problems at this point? Are there any type mismatching and stuff like that? Should be no problems, right? Then we get to the swap subroutine. Okay, this is a call to the swap subroutine. What is this ampersand doing in front of A? It's taking the address off, right? And is that going to be okay? Is that by itself a problem? Does it match what swap is expecting? Yes. It does match. Okay, so when you look at the parameter of swap, what is this part saying? It's saying this is the first argument or the first parameter of swap. It has a name of x known to swap as a function itself. But what is the type of x in this case? Is a pointer to an integer, or otherwise known as an address of an integer? Okay, so either way it's okay. You can call it an address, or you can call it a pointer to an integer. Okay, do you guys still remember the cookie analogy? Okay, so is x a piece of cookie, or is it the instruction to find a cookie? It's the instruction to find a cookie. Okay, you don't want to eat the instruction. You want to eat a cookie, but not the instruction. Are we doing okay so far? So in this case, we have two instructions. We have the instruction to find one cookie, and the instruction itself is x. So x is not referring to the cookie, it's referring to the instruction to find the first piece of cookie. Y is the instruction to find a second cookie. Is that okay? All right. Then what makes t? What is t in this case? T is in the instruction, right? T is an instruction to find a cookie. It is not initialized. In other words, it's just some blank piece of paper. It does not actually contain any instruction yet, but that piece of paper can only be used to store the instruction to find a piece of cookie. It is currently blank. Okay, it's a local variable. It is not initialized at this point. What is the first line of code actually doing? It says t equals x, which normally is a very simple thing, right? We copy whatever is in x and make t identical to x. In this case, we do exactly the same thing. But what are we actually copying? Are we cloning a cookie, or are we just cloning the instruction to find a piece of cookie? We are cloning the instruction. So t becomes the same instruction as x, which is the instruction to find the first piece of cookie. Did I do anything with that instruction? Did I actually get to the cookie? No. What would be a good clue that you're actually getting to the cookie itself, given the instruction? What is the name of that operator? Okay, what does it look like when I say, hey, follow this instruction to get to the cookie? Asterisk, and what do we call that operator? Dereference, exactly. Do you see any dereferencing in swap? Nope, nothing, right? There's no dereferencing operator whatsoever in swap, which means all that we are doing is what? With only the instructions. Exactly, we are just copying stuff around, but they are all instructions of instructions to find cookies. But we actually did not do a single thing about cookies at all. Because in the second instruction, we're basically saying, hey, overwrite the instruction to the first piece of cookie with the instruction to find the second cookie. Did I actually get to the cookie? Nope. All I'm doing is to change the instructions. And then this one, the third instruction, or the third line of code, is just copying t, which is now a clone or a saved copy of the instruction to find the first piece of cookie. And I say overwrite the instruction to find the second piece of cookie with the instruction to find the first piece of cookie. So what I have successfully done is swapping. Okay, I did swap, but what did I swap? The instructions, not even the locations. Okay, just the instructions. So the instruction to find the first piece of cookie is now the instruction to find the second piece of cookie. The instruction to find the second piece of cookie is the instruction to find the first piece of cookie. I have exchanged the instructions, but not, and I didn't do anything about cookies. Okay. So when this is all done, when swap is going to return, every instruction is going to be destroyed because all parameters and also all local variables will disappear at the end of the execution of a subroutine. So I'm going to put a whole lot of stuff into the trash can or the recycle bin or the shredder. What am I shredding? Am I shredding cookies? That would be a waste. No, I'm not shredding cookies. So what exactly am I shredding? I'm shredding the instructions, which I successfully exchanged. What happened to the cookies that these instructions is supposed to lead me to?
Absolutely nothing.
Absolutely nothing. Okay, so that means by the time I get back to the main function, which is the return statement, did anything happen to A or B? Absolutely nothing. The program does not crash. Okay, it just didn't do a single thing that is useful. Is that okay? If I am to fix this program, how am I going to fix it? In other words, how do I exchange so that where the first piece of cookie was, it will store the second cookie, and where the second cookie is, it will store the first cookie. How do I exchange the cookies themselves and not the instruction to find the cookies?
You have to dereference them.
I have to dereference. Okay, so this part I'm just going to put it here, but I will undo the changes. Okay. So if I'm going to do the undoing of the, and if I'm doing something with the cookies, what am I going to do with these instructions? Okay, I'll give you one, potential answer. Oh, we just need to follow the instructions, right? We'll just keep doing this. Everything where we have the instructions, we'll say follow the instruction. There's a problem with this one, okay? And what do you think will happen in this case? Go ahead. It will crash, okay? It means, crashing means the program is going to exit, or it will do something wrong before we get to the return statement, okay? And when do you think it's going to crash? On the first line in swap, okay? On the first line in swap. Okay, let's go back to this program here. So let's just assume that we are calling swap with the address of A and the address of B, and then we get to this part here. So this means parameter x is now the address of a particular integer, which is good. Parameter y is the address of another integer, which is also good. What about t? Well, t is a local variable. What is one thing about local variable that I have emphasized for the entire semester? Well, they get destroyed at the end of the execution of the function, but what else? What else do you have to be careful about with local variables? What kind of value do they start off with? Some kind of random, leftover, unknown, undetermined value. Okay, so t as the instruction to find a piece of cookie is uninitialized. You have a piece of paper which is supposed to be the instruction to find a piece of cookie, but all you have is gibberish because it's a local variable, okay? Which by itself is not a problem. It is a problem when you use it. What happens when we have asterisk t on the left-hand side of the assignment operator? Follow the instruction. What is on the instruction? It's all gibberish, right? So it might specify, go to the North Pole somewhere, to find a piece of cookie. And that's when the program will crash, because it will try to follow the instruction, and most likely it is a location where your program does not have privilege to access. Okay, so that didn't work. But what do I need to do to fix this program then? Do I really need to, does T really has to be the instruction to store, the instruction to find a piece of cookie? No. It should be like this, right? This is the proper code. This is the actual correct answer to swap. Because in this case, it's okay for T not to be initialized in this case, because I am not even using it for anything in the first statement. The first statement simply means go ahead and follow the instruction to find the first piece of cookie and copy that to T. So T can be uninitialized in this case because I am initializing it. Okay? I'm not doing anything with T in this case, in the first statement. So this is the proper answer, but to change the question back to the original form, I'm just going to change it all back to the original one so that, when you study, you know this is the original one.
Yeah, this is the T had for that.
Oh, T has the asterisk. Yep, there you go. Because if T did not have the asterisk, there would be a type mismatch error. Are there any questions about number 3? This is question number 3.
So right now it will crash.
Right now, it will not crash, but neither will it do anything useful. I think with this one, we specifically actually debugged this program in one of the classes. We went through the debugger, we actually looked at the parameters as well as the result of the function itself. All right, that's number 3. Let's take a look at number 4. Number 4 is like this. Okay. So we start, okay, let's read the question itself. The question says, assume that when we run the program, we supply the following as the input to the program. The input to the program is, AS23, RT12, 67CD, exclamation point, oops, you guys cannot see it, X1, 2. Okay, that's the input to the program. I want to find out what is the value of X before the return statement executes in main. In other words, by the time I get to the return statement, what is the value of X? So everything is determined by sum, because I call sum as a function, and whatever sum returns is whatever I will actually store into X. So now I have to go back to sum and find out what sum is going to do. This is the definition of function sum, and then we have to find out what it's going to do. Do you see anything that resembles your previous program? A little bit, okay? I didn't do it exactly the same way as last time, but it does resemble a little bit. So let's go through the definition of sum and find out what it is going to do. We have local variables. We have local variable r, and then we have local variables x, y. I could have combined the declaration of all 3 onto the same line. I could have said, int r, comma, x, comma, y. It will do the same thing. But since r has a different function compared to x and y, that's why I kept them separate. All right. So we have a while loop, and as I usually do, I always, contain the statements inside the while loop using open and close curly braces. The condition of the while loop is kind of long, okay? So we have to figure out what this is going to do. All right, so tell me what this statement is going to do. Okay, first of all, I'm going to add 1 extra pair of parentheses just so that it is clear about the ordering of the expressions. Okay, the first part is pretty clear. Okay, the first part is clear because this is what we need to do first. Are there any questions about this part? Is the part that we have to do, we have to execute first. Is that okay? Oh, by the way, let's look at the whole thing first. And can anyone tell me, overall speaking, at the top level, what type of expression is this? We can see several types of operators. We can see assignment here. We can see comparison. We can see logical and we can also see what else? A comma, right? At the top level, which one is it? When you look at the grouping of the parentheses, what is the last operation that we are actually performing? The comma is the last one. Okay. So let's go ahead and draw a picture of this statement, just so that we know how the whole thing is organized, how it's structured. All right, so we'll start at the lowest level and then build our expression up. So at the lowest level, we have scanf, right? I'm not going to specify the detail of the scanf here. Okay. We have the assignment operator. Is this too faint? Can people in the back still see it? No? Okay. Let's pick a more solid card. Here we go. This is R, this is scanf, blah, blah, blah. So the assignment operator is taking this as the left-hand side, this as the right-hand side of the assignment operator. Are we doing okay so far with that part of the expression? Okay. On the other side, we have r compared to 0. So we have r, 0, and this is the comparison operator. Is that okay? And then we also have r compared to 2. So we have r, 2, and then compare, but this time it's comparing for less than. What do we do with the results of the greater than or equal to 0 and the result of less than 2? 2 ampersand is the logical and. Okay. So this will combine the results of the 2 comparison. Are we still doing okay so far? So now we have this, which is the entire one side of one thing. This is the entire thing of the other side. How are these two connected? Which operator connects them? The comma. All right. So the comma is an operator, but what does it do? Sorry?
Returns the last item.
It only returns the value of the last expression. So in this case, the assignment is the first expression. It doesn't care about the value of the first expression. It just tosses it away. Whatever the ampersand or whatever the logical and is the result of the comma expression. Does it have any specific order to evaluate? With a comma separated expression, it always evaluates from left to right. Okay. So it will always perform the scanf first, change the value of r as a variable, and then move on to evaluate the greater than or equal to. And if that is not true, if that is true, then we'll also go ahead and evaluate whether r is less than 2. Yep.
So if you wanted to make this a for loop, you could just change the comma to like a semicolon?
No, you have to keep the entire thing. Because we always have to perform this first so that r has a value for comparing. So the entire, if I want to turn this into a for loop, this is one way to do it. If you want to turn this into a for loop, then we'll have no initialization and no post operation.
Oh, okay. I was just confused. I thought the scanf part was the initialization.
Nope, it's not. We are performing the scanf for each iteration, and that's why it is not the initialization. It is a part of the condition. It's just that I cannot determine right away from scanf itself. I cannot determine whether to stay in the loop or not. I have to compare the result of scanf in order to make that determination. Okay, so now that we know the structure of this entire expression, what does it mean? It means that we're going to stay in the loop as long as what?
We don't read a number comma.
Yep. As long as r is greater than or equal to 0, which means r is not negative. Why would I want to get out of the loop when r is negative? Because end of file. Okay? If it's end of file, there's nothing I can do to remedy that situation. So it's time to get out when r is less than 0. On the other hand, I also want to stay in the loop only if r is less than 2. What happens when r equals to 2? Exactly, I would have read the 2 things that I'm supposed to read in scanf. Then it means I'm done, okay? So when r is greater than or equal to 0, it means it's not end of file yet. When r is less than 2, it means I did not read everything that I'm supposed to. That means, in the input, there's some kind of obstruction, okay? Something that is not supposed to be there. Well, when something like that happens, what do you think this line does? Or these two? It just reads it, toss it away, okay? Whatever is preventing me from reading 2 things at the same time, I'm just going to toss it away. Okay? And we have seen this code already in the previous homework assignment. When it does get out, what does it mean? When we get out of this while loop, what are the 2 conditions that can get me out of this loop? The first one is when r is less than 0, which means it's end of file. which also means x and y would not have any usable value. Okay, so let's assume that is not the case. What is the other way I can get out of this loop?
Read two things.
When I have just read two numbers, and those two numbers will be put into x and y as local variables. What am I doing with x and y with the return statement? I'm just calculating the sum of those two numbers that I just read in, and they have to be comma separated in the input. I'm just going to return the sum. All right, so knowing this is what sum as a function is going to do, let's go ahead and see what it will do with this input. So I'm going to scroll this up here. Okay, so the first attempt is to read a as a number, comma separated by comma and then another number. Would it succeed? It will return what? It will return a 0 because I don't even get a number to begin with. And if it does return a 0 in the loop, what is it going to do next? It will do a scanf, get rid of that one single character, which means I'll be ready to read lowercase s. Same thing happens, right? It will get rid of that one, and then it will read 23. Yay! Even the comma, yay! And then after the comma, what do we get? R. Is that the beginning of an integer? No. So what do you think scanf will return in that case? It will return 1. Is 1 less than 2? Yep. Is it greater than or equal to 0? Yes. So it will stay in the loop. It will basically clear away R, okay? And it will be ready to read T and so on. But everything is going to be okay after I clear away T, because then it will read 12. It will be reading 12 as a integer, a comma, and the 67 as the second integer. Well, that's okay, because when it reads 12, comma 67, then it will be satisfying both requirements of the scanf. R will become 2, we get out of the loop, and it will just return 12 plus 67. And that becomes the return value of sum, which is 79. So sum returns 79, x becomes 79. By the time we get to the return statement, x has a value of 79. Okay. Are there any questions about this one? Yep.
So since it's a comma separated expression, you just toss away the 23 with the sum, kind of?
The toss away the 23.
Find the sum.
It's because when it tries to read 23, it will read 23 as the first number. It will successfully read the comma, but when it tries to read the second number, R does not match the beginning of a number, and that's why it will fail to read the second number, and scanf will stop right there, but it will also return a value of 1, saying that of the two things that you asked me to read, I can only read one of them. Right? Are there any questions about question number 4? No questions? All right. Let's move on to question number 5. Question number 5 is, well, I'm not sure whether you guys like this kind of question or not, but this is kind of the general format of exam 2 is I give you the code, you tell me what it's going to do. So this one has arrays, okay, so we'll take a look at what this program is going to do. Observe the following program, blah, blah, blah. What is the value of x before the return statement in main? Okay, very standard format of this particular exam. So I want to know what is x here. And no, I will not take an answer of x has whatever x bracket 2 has. Okay, that would not be a valid answer. I want to know the exact value of x by the time we get to the return statement. All right. So that means we have to follow this code and find out exactly what this loop is going to do to all elements in A. Well, at least up to A bracket 2, right? What do you think it's going to do? Well, let's take a look at all the entire code of main first. We have a constant, which is A size defined to be 5. We have a prime number, which is 7. I allocate A as an array, it has 5 elements because A size is 5. I and X are uninitialized integer variables. Are there any questions about these 5 lines? And then we have a for loop. The for loop has the initialization of I equals to 0, which means we'll start with a value of 0. I is less than A size is the condition to stay in the loop, which means I will go from 0 to 4, okay, as far as the statement in the loop is concerned. When it gets to 5, we get out of the loop. The post operation is plus I, which means we just want to increase the value of I by 1. This is the post operation, which means it is done after the body of the loop, which is the portion that I have highlighted here. So we just have to figure out what this is going to do. Okay, I start with 0. 0 times whatever is always a 0. 0 plus 2 is 2. 2 mod 5 is 2. Okay, so I'm just going to write it down on the whiteboard. The first one, A bracket 0 has a value of 2. Is that making any sense? And then we perform the post operation. I gets increased by 1. And then we go back to the same statement. What about A bracket 1? What is the value of A bracket 1? Well, let's figure out. What is 1 times 7? 7. 7 plus 2 is 9. What is 9 mod 5? 9 mod 5 is the remainder of 9 divided by 5, which is 4. So this one is 4. What about A bracket 2? 2 times 7 is 14. 14 plus 2 is 16. 16 mod 5 is 1. The remainder of 16 divided by 5 is 1. Well, technically speaking, this is all I need to do to figure out the answer. Right? Because the other 2 elements really do not matter. What do you think the other 2 elements are? Don't you see these numbers are just off by 2? 4 is off by 2 from 2, and 1 is off by 2 from 4. If you use modulo 5 arithmetics. Because there's no 5, it goes back to 0 and it goes to 1. So what do you think the next number is going to be? It's going to be a 3, and then the next one is going to be 0. Yep. So even without evaluating the expression, you can kind of work your way through. It's all about modulo arithmetics. And everything you do on a computer is based on modulo arithmetics. Even though it's not spelled out, it is. Okay? I'll give you one example here. Go to this part here. Okay, so we'll say int x and y. Okay. Just x is fine. So when we say x is 45 and x gets x times whatever number we have here, okay? This is actually implicitly, okay, let me scroll up because I know some of you in the back cannot see it. This is actually modulo arithmetic already, because what is not seen to you is this part here. There's an implicit mod, but this mod, or whatever we are modding it with, is a really big number. Okay, it's basically 2 to the power of, now this is not the actual power of, okay, I don't use the proper word to do it. So because int is x, so this is 2 to the power of 31, that's it. There's an implicit mod already. It's just that we don't see it. So everything you do, okay, as far as integers are concerned, everything that you do on the computer is implicitly already using the modulo arithmetic. It's just that the dividend is so big that most of the time we don't have to think about it. Getting back to this one, are there any questions about number 5? Yep.
So what was the answer to that?
The answer is 1. But with every single one of these programs, you can actually type it in and run it, and then in GDB you can observe how it works and find the answer too. And this is the last question. The last question is same kind of format, except this one is a little bit more kind of involved, just a little bit more. Okay, so we'll start with the main function. The main function has a const int a size equals to 5, typical thing to define the size of an array. We declare a local variable a, which is an array. Oops, sorry, I need to scroll up so you guys can see it. And then I have the initialization of all the elements in this particular array. So we have 2, 5, 3, 7, and 1 as the values of each individual element of this array. And then I call the subroutine, but the way I call the subroutine is a little bit funky. I say, well, let's go ahead and call the subroutine, but with a size minus 1 as the parameter passed to a size of f. Hold on a second here. Is that a problem? Because it seems like I'm reusing the name a here. I'm reusing the name a size here. Is that okay? It is okay because they're all local, okay? In other words, this a size is local to main as a function. This a size is local to f as a function. And there's no problem when you use the same name again and again, as long as they are local, either a local variable or a parameter. Okay, so the question is, what is f doing? Well, when you look through this code here, it starts with, with I equals to 0, and we stay in the loop as long as a size divided by 2 is greater than I. And then at the end of each iteration, I basically just add 1 to I. This looks complicated, but for those of you who remember what we did with the swap subroutine, you might recognize this sequence of assignment operations. What is it really doing? Okay, first of all, does it look like the swap sequence?
Yeah.
Okay, it is the swap sequence. What am I swapping? What am I exchanging? The value of element I with the value of element a size minus I minus 1. So what is it exactly doing? What is a size in this case? What did I pass to it?
4.
I passed 4 to it, right? Okay. And so that means when I is 0, what is this portion here? It's 3. When I is 1, what is this portion? 2. When I is 1, this is 2. Is that okay? What about when I is 2? What do I have to think about it when I is 2? Well, let's think about this condition a little bit here. When I is 2, what is the value of this expression? A size is 4. 4 divided by 2 is 2. 2 is less than 2 is
False.
false. Okay, so I only really have to worry about I being 0 and I being 1. So what it's doing is it's exchanging the first element with the last one, the second one with the second last, but it's assuming a size is the correct number of elements in the array. I did not give it 5. I gave it only 4, right? So it will only do that exchange with the first 4 elements of the array. It will leave the last element, the actual last element, alone all by itself, is not touched. So that means by the time when we get back to the return statement here, the first element will end up with a value of 7. The 4th element will end up with the value of 2, because these 2 will be exchanged. The second one and the third one will be exchanged as well, which means a bracket 1 will have a value of 3, a bracket 2 will have a value of 5. But the last element, which is a bracket 4, is left alone because the subroutine F actually does not touch it. So that one is left alone. So if I just spell out the correct answer, because the answer is, the question is asking list and specify the values of all elements. So I would be expecting an answer like this. A bracket 0 will have a value of 7. A bracket 1 has a value of 3. A bracket 2 has a value of 5. A bracket 3 has a value of 2. And A bracket 4 keeps its original value of 1. That is the answer. Oops, sorry. Scroll up again. That is the answer that I'm expecting. Now, if I change the parameter, instead of passing A size minus 1, if I pass A size, then it would just exchange the exchange the first with the last, second with the second last. It will leave the middle element alone. Yep.
Pass by value, you can actually alter A as it stands.
There's no way to pass an array by value.
Right.
It is always passed by reference. Yep. So whenever you pass an array into a subroutine, it will do something to the array itself. It's not going to do it to a copy of the array. Are there any questions about this particular one? All right. So it is 10:21. I'm going to stop the lecture. In the lab portion, what I'll do is I will go ahead and type these programs in and run each one through, okay? Just to double check and verify that the answer is in fact correct. And if in case of you guys having any in case you guys having any questions, I can answer those questions while we debug the programs, so that we can say, okay, stop here. I want to look at this variable at this point of the program. Okay. All right, so we'll go ahead and take a 10-minute break. When we come back, we'll actually go ahead and test each and every single program to make sure they do what they're supposed to.